Assalamu alaikum. We have studied an AC circuit containing pure capacitor in the previous video. In this video, we will discuss an AC circuit containing only an inductor. For that, I consider an inductor of inductance L connected to an alternating voltage source. This is an alternating voltage source which is connected across this inductor of inductance L. If it is so, the instantaneous value of alternating voltage is given as V, which is found to be equal to Vm sin omega t. I take this one as equation number 1. Due to this alternating voltage, the alternating current flows through this inductor. As a result, it produces a varying magnetic field around this inductor. So we know very well, whenever the electric current flows through a conductor, it produces magnetic field around it. Similarly, this alternating current flowing through this inductor will produce a varying magnetic field. So the magnetic flux linked with this coil changes with time. According to Faraday's law of electromagnetic induction, whenever there is a change in the magnetic flux linked with a coil, there will be an induced EMF in that coil. So an EMF is induced here. The EMF induced in this coil is expressed as epsilon, which is found to be equal to rate of change of magnetic flux linked with the coil. So change of magnetic flux is d phi b. Rate of change of magnetic flux is d phi b divided with the time dt. Okay, and here the magnetic flux induced here always flow in a direction to oppose the cause according to Lenz's law. So we have a minus n here. Then we know one more thing. Magnetic flux linked with a coil or conductor is directly proportional to the current flowing through the conductor or the coil. Okay, so here d phi b is directly proportional to I. So here, when I remove this proportionality, I have to include a constant along with the equal to sign. Okay, I write I here as such. Then phi b is written as, here in the place of constant I write L. L is the proportionality constant, which is nothing but self-inductance or inductance of this inductor. Correct. Now in the place of phi b, I am going to write Li in the above equation. This I am going to use here. So what I will get? I will get this epsilon equals to minus d upon dt of Li. Okay, here L is a constant, so we do not differentiate this, so it is taken out. It is written this way: minus L di upon dt. This is the value of epsilon. This I am going to write here. So EMF induced in this inductor is represented as epsilon. This is found to be equal to minus L di upon dt. Okay, I take this one as equation number 2. Now I am going to apply Kirchhoff's voltage rule here. Applying Kirchhoff's voltage rule. Voltage rule. So what does it say before doing so just draw a line here. What does Kirchhoff's voltage rule says? Kirchhoff's voltage rule is applied to a closed loop. According to it, sum of voltage in a closed loop is equal to total EMF in that closed circuit or loop. Clear? So I'll write it here. Sum of voltage in a closed loop is found to be equal to total EMF. Total EMF in that closed loop. Clear? And here voltage. The sum of voltage is nothing but this. What is that? V. And the total EMF is epsilon. Got it? Now I'm going to substitute the value from equation number 1 and 2. So V is found to be equal to Vm sine omega t, and epsilon is equal to this minus L di upon dt. But here I will write only the magnitude. It is not necessary to mention minus L here. Only magnitude I write. So I skip minus sign. Right? Di upon dt. See, it doesn't matter in what direction the EMF flow. Okay, in what direction the induced EMF flow in the coil. So I have taken only the magnitude without by skipping the minus sign. Next, my aim is to find the value of I. So I keep a di at one side, and the remaining terms are taken to the other side of this equation. Here L multiply, when it is taken to the other side, it will divide. So I will get this Vm divided by L sin omega t. Now here dt is in a denominator. When it is taken to the other side, it will go to a numerator. So it will multiply with this part. dt is what we are taking. Here I take this one as equation number 3. Okay, this can be rearranged and written this way. I rearrange it as di equals to Vm upon L. Vm upon L sin omega t dt. This is the equation number 3. Now, to get I from di, I have to integrate this. It is in differential form. The opposite of differentiation is nothing but integration. If I integrate this, I will get I value. So I am going to integrate this equation number 3. Integral of di is going to be equal to this. So here Vm upon L is a constant. Here Vm stands for peak value of voltage, peak voltage, which is a constant, and here L is the inductance of the inductor, which is again a constant. We do not integrate a constant, so it is taken out. I skip one step here. Vm upon L is written outside the integration. So integral of sin omega t dt. Now I am going to integrate this and see what happens when you integrate. For integration, di becomes I. We know integral of dx is x. Similarly, integral of di will be I. Is found to be equal to Vm upon L. Now when I integrate sin omega t dt, let's find out what do we get. We get minus cos omega t divided by omega. Along with this, we get an integration constant. This a constant is obtained here. This is what I obtain here. Yeah. And then this I. Here Vm divided by L. Now I bring the omega outside, so it will multiply with the L. Okay. Now, so what remains here inside the bracket is nothing but minus cos omega t plus constant. Here this constant is called as integral constant or integration constant. Okay. And here, if you observe, this term is a time dependent term, whereas the constant that we have obtained do not depend on time. So it becomes 0. It becomes 0, so we remove it. Okay. And by doing so, what do we obtain here is what remains here is nothing but this. I equals to Vm upon omega L. Within bracket we have minus cos omega t. Now I'm going to make certain changes to this. What is that? Here we know minus of cos omega t. Minus of cos omega t is equal to sine of omega t minus 90 degree. So in the place of 90 degree, I write pi by 2. So minus cos omega t can be written as sine of omega t minus the pi by 2. Okay, this is what I am going to write here. So this I will substitute in the above equation. So what I will get if I do so, I will become I equals to Vm upon omega L. Within bracket I write sine of omega t minus pi by 2. Here pi by 2 is nothing but 90 degree. What is the value of pi by 2? Pi by 2 is 90 degree. Clear? Remember this. The next here, omega is the angular velocity. When it is multiplied with the inductance of the inductor, the omega L. No, the product of angular velocity and inductance is nothing but reactive inductance. Clear? What is this XL? XL is nothing but reactive inductance or inductive reactance, you can say. This inductive reactance is actually the resistance offered to the flow of current by an inductor, or in simple words, this inductive reactance is actually opposition to the flow of current by the inductor. Clear? If current flows through a resistor, then the opposition of current to the flow of current, the opposition to the flow of current by the resistor is referred as resistance. Whereas when the current flows through an inductor, the opposition to the flow of current by the inductor is referred as inductive reactance. Clear? So I'm going to replace omega L with XL here. Next step, I'll get this. So Vm upon XL sine of omega t minus pi by 2 is what I obtain here. And we know very well, when voltage is divided by resistance, we obtain current. So V upon R is nothing but I from Ohm's law. In similar way, Vm, there we have Vm in the place of V and XL in the place of R. So what do I obtain here is nothing but peak or the peak current or maximum current. So I replace this with Im. Next step, I get this. I equals to Im sine of omega t minus pi by 2. This is the final expression we obtained, and it represents instantaneous current, instantaneous value of alternating current. Clear? I take this one as equation number 4. Clear? Here, equation number 1 provides us instantaneous value of alternating voltage, and equation number 4 provides us instantaneous value of alternating current in the circuit. So, for better visibility, I am going to box this. I boxed this. Take this in. I'll do the same thing with to this one as well. The two important equations. One provides instantaneous value of voltage in the circuit, and this equation provides us instantaneous value of alternating current in the circuit. Clear? Now I'm going to relate these two. If you observe these two things, you may find that here the phase angle in voltage is omega t, whereas here the phase angle is omega t minus pi by 2. So it is less than 90 degree compared to the voltage. Got it? So we can say that V, voltage, leads current by 90 degree. So 90 degree can be written as pi by 2. Got it? Now I am going to represent this with the help of a graph. I am going to draw a graph with the help of a waveform diagram. I am going to explain this. Now there is one more method by which it can be represented. It can be reversed as, I can say, I lags behind V by 90 degree. This is another way of representing this. You can remember it. Now I draw y-axis, then this is the x-axis. Okay, along x-axis I take omega t, which is nothing but time angle. Clear? And here along y-axis I take voltage V. First I am going to represent voltage. For that I'll use a sinusoidal wave. See? This is a sinusoidal wave which represents voltage, alternating voltage in the circuit. Clear? This V. Now I am going to represent the current in the circuit. For that, according to this equation, when voltage is at 0, this will lag behind the voltage by 90 degree. So when it starts here, by that moment, see, look at this carefully how I draw it. At that particular time, the current will be the phase angle of the instantaneous current is at a minus 90 degree angle. Okay, so I represent this below. Yeah, the center point. This is the center point here. Same thing here as well. See what I do? When it is at 0, when the voltage is at 0, the current will be at minus 90 degree. Okay, so I start from here. When it reaches plus 90, this will reach 0. Yeah, I hope you have understood. Now we continue as such. Now this continues. This is how one can draw the waveform diagram of voltage and a current. Here, this green waveform represents a current. So I represent letter I. Okay. Now if I continue, the starting point will lie somewhere here. This is the starting point of this. Okay. Anyhow, now I'll draw the phasor diagram. For that, I continue this x-axis. So look at this carefully, how I draw the phasor diagram. Most of the students find it difficult to draw the phasor diagram. So it's too simple. I take this is the x-axis. Now I draw y-axis. Okay. Now see, to draw the phasor diagram, now I take a point here. Okay. Now from that point I draw a line. So this shows that I have taken 2 points, one at the voltage waveform, another at the current waveform. Both are having the same value for omega t. Clear? There is 0 here. At this point, we have a pi by 2, and here we have pi. So it goes like that. Here it is a 2 pi. Here pi value is, what is the value of pi? Pi is nothing but 180 degree. Okay. So here it is 0, it is 90, it is 180, here it is 360. Here it is 270 degree. Clear? So at some point here, the value may be around 45 to 50. Okay. So the same here. Now to draw the phasor diagram. Actually, the phasor diagram shows the projection of the waveform. What is a phasor diagram? Phasor is nothing but the projection of the waveform diagram. Okay. So I draw the projection here. To represent the projection, I draw a line here which moves towards this y-axis. Okay, this is what I have done. Now I'll do the same thing from this point as well. I'll draw a projection. Okay, this line represents the projection. It projects on this line. Now then, first I'll draw the phasor, which represents the voltage. Right? See, this point have a omega t value to be around 45 to 50. So while drawing this line, a phasor, care must be taken that it must make an angle of 45 to 50 with the x-axis. Clear? This is the phasor. And name this one as OE. This represents the voltage. Okay, so similarly, I draw a phasor which represents the current. So it will be here. So look at here. What is the angle between them? The angle between these two phasors is something but 90 degree. Okay, it is a 90 degree. One acts in the upward direction, one acts in the downward direction. So this shows that current lags behind voltage. Okay, this represents voltage and this represents the current. Okay, I hope I have understood. Now, from this point, if you draw the projection, now it falls on this. Okay, the same I do here as well. It's a projection of this phasor on the y-axis. Now, this will provide us, this projection will provide us the value of instantaneous value of alternating voltage. This is the value of V. This is nothing but Vm sine omega t, and this height from here to here, which is obtained from the projection, provides us the value of instantaneous voltage. That is Im, right here. The space is not sufficient, so I write it this way. This Im sine of omega t minus pi by 2. Okay, this is the what it represents. This height represents. Okay, and here length y provides us V value. Similarly, this length OB, I take it as OB. It provides I, value of I. Okay, and its a projection provides us Vm sin omega t value. And here this angle provides us omega t. Okay, and here this phasor rotates with the angular velocity omega. These are the information we obtain from the phasor diagram. I hope I have understood. Now, what did I say? This angle is called as omega t. This angle. This you need to keep in your mind. That I have told you earlier. Suppose the point, point at this this line, if it crosses this point here, and its value is around 45 to 50 means that is nothing but the value of omega t. This is what we obtained here. So we have to keep that angle here while drawing the phasor diagram. So from the phasor diagram, one thing is clear, that I lags behind V by 90 degree. Okay, I hope the video is useful. If you have any kind of doubt related to the topic, kindly put a question in the comment section. Thanks for watching.